Okay, before I do tonight's lesson, I want to clarify a couple of things that I saw today in class. Drove me a little crazy, and there was some confusion when you guys were working some of these problems, especially when you were working the problems on today's homework, where you had an inverse trig function on the outside. And I want to work one of those to make sure that you're going to get this right. So we got to make sure we got a pen working here. Let's go. I seem to be a fan of the blue. So let's do that one. I want to work problem number 7 because I saw some crazy things today in class on number 7. And number 7 on the worksheet was arc cosine of the sine of 4 pi over 3. And I want you to clarify before you even get started on this problem that your answer is going to be an angle. My answer is an angle because the very last thing I'm going to do is an inverse trig. So although the inside function is going to work out to be a fraction, my final answer is going to be an angle. So what we're going to do here is we're going to work the inside function, and this is where I saw some crazy stuff. This is back from like the first week of class. We were doing exact values, and we learned things, and we said SOHCAHTOA. We figured out that pi means 180 degrees, and we did degrees to radians, and we did like the sine of 4 pi over 3 a lot. And there were no restrictions on where to draw this angle. We put it in the right quadrant. We labeled the sides. And we were going great. But today there was a lot of confusion because some people labeled a triangle with like 4 pi on the opposite and 3 on the hypotenuse, and I don't know what you were doing there. But well, I do know what you were doing. You were confusing that with arc sine. So let's go through this and answer inside out. The sine of 4 pi over 3. This is not inverse sine, it's just sine, which means we need to find the fraction after we draw this angle. So I'm going to draw 4 pi over 3. 4 pi over 3 is in quadrant 3. This is not inverse sine. It does not matter where that triangle goes. 4 pi over 3 is in quadrant 3, which is with a 60-degree reference angle. So that's a 30, 90, so 30, 60, 90 triangle. And we're going to label our sides as a -1, negative square root of 3, and then a 2. And so the sine of 4 pi over 3 is going to be opposite over hypotenuse, which is negative square root of 3 over 2. SOHCAHTOA is all we're doing there. Now that we have found that, we can find the arc cosine of negative square root of 3 over 2. Now we're going to find an angle that has a cosine of negative square root of 3 over 2. We're going to draw a different picture or another picture. This is where you have to worry about the range for arc cosine because this is an inverse trig function. This inside function was not an inverse trig function. But inverse trig function, you worry about where to draw it. We draw any arc cosine in quadrant 1 or 2. This is negative, so I'll put it in quadrant 2. So I'll put adjacent over hypotenuse. There's our opposite. That's a 30-degree reference angle, which means that my answer is 150 degrees, and since we're in radians, we're going to call this 5 pi over 6. So anyway, if your outside function is an inverse trig function, your answer will be an angle. Alright, so I just wanted to clarify that. Okay, so what we're going to do tonight is we are going to look at algebraic expressions for composition functions. So let's take a look at an example. Let's do the cosine of the arctan. Now this all looks familiar, at least a little bit familiar from what we were doing in class, but now instead of giving you a fraction, I'm just going to call this x. So what I want is an expression to find the cosine of the arctan of x. And we're going to do this just like we set it up in class. We're going to draw this. This represents an angle, this inside function, the angle whose tangent is x. So I need to think about the tangent of some angle theta is equal to x. And then once I do the outside function, I'll find the cosine of that. But for now, I'm going to draw this angle. If x is positive, and I don't see a negative sign there, we are going to put this angle in quadrant 1. And this is our angle that we're looking at. The arctan is x, or the arctan of x. So the arctan is the angle. So we need to think about this as x over 1. And tangents, two sides, are opposite and adjacent. So if I put an x on the opposite and a 1 on the adjacent, I can use the Pythagorean theorem to find the hypotenuse. So this is, what you have here, this is like a picture of the angle whose tangent is x, or the picture of arctan of x. Now if we want to find the cosine of this angle, we're going to have to find this hypotenuse. So if you do the Pythagorean theorem, you're going to get the square root of 1 plus x squared. So we can now find the cosine of this triangle, of this angle here, by doing adjacent over hypotenuse. So my answer is 1 over the square root of 1 plus x squared. Let's do another example. Let's do the cotangent of the arc sine of 2x. So what I'm going to do is I'm going to draw the picture for the arc sine of 2x, and then I'll find the cotangent of that. I need to think about this as the sine of some angle is 2x. So let's see if we can't draw that picture. Alright, so we're going to put this over here in quadrant 1. A little noise in the hallway, sorry. And I'm going to think about this as 2x over 1. So I'll put my theta here. Sine is opposite over hypotenuse. And then here you need to think about Pythagorean theorem. We can have the adjacent side squared plus b squared equals c squared. So this adjacent side is the square root of 1 minus 4x squared. Okie dokie. So we can find the cotangent of this angle by doing cotangent is adjacent over opposite, right? Yes, adjacent over opposite. Instead of opposite over adjacent, it's the opposite of that. So my answer here is adjacent over opposite. How's that look? That looks pretty good. Alright, so tomorrow in class we're going to try some of these where we've got, I guess right here we've got variables instead of just a fraction.